This is the review for your AP Physics test tomorrow. Number 39, I believe, and 54, I'm not doing on here because they're fairly simple. Basically, on 39, you need to know that if it's moving at a constant speed, the acceleration is 0. With the block sliding across the table, you need to know that if it's moving, it's got kinetic friction, and if it's sitting still, it's got static friction. All right. So now that we've established that, let's go on to talk about number 69 first. So there are 16 ounces in a pound. Calculate the equivalent 1 ounce force in newtons. So 1 ounce is, 16 ounces are in 1 pound. Forgot the 1. There we go. And then from there you would do 1 pound is 4.54 newtons. Multiply across the top, divide by the bottom, and you should get that there is 0.28 newtons in 1 ounce. Okay, number 71. Basically, on that one, you know you're looking at the the free body diagram on the board and only the board. So basically, you're going to have a force up from the crate, a force up from the crate. These will be normal forces. You're going to have the force of gravity down for the board itself, and then you're going to have another force of gravity from the crate. Now you can give numbers to these things, right? So the force of gravity from the crate would be 300 newtons, and the force of gravity on the board itself would be 100 newtons. I'm just multiplying 10 times 30 and 10 times 10, which means that there's a total downward force of 400 newtons, which means that there's got to be a total upward force of 400 newtons. So these two have to be 200 and 200. Okay? Next one, number 81. A 10 Newton force is applied to an object which then accelerates at 4 meters per second squared. What is the mass of the object? Okay, so on that one, you just do F net equals MA, and you get 10 equals M times 4, and so M would be equal to 2.5 kilograms. All right, on the next one, number 84, this is the ever popular elevator problem. Basically, you need to know that, first of all, this is the free body diagram. You've got an up force, that's the normal force. This normal force is also the force of the scale. And then you've got the force of gravity down, which means that the net force should equal mass times acceleration. We know this due to Newton's second law. Normal force minus the force of gravity equals mass times acceleration. And we don't know the force of gravity, but we do know that mass times 10 will give us the force of gravity. And now we can solve because we know everything except acceleration. We know everything except the normal force. So for the first one, we would do normal force minus 1,000, which is 100 times 10, equals mass times acceleration, 100 times 1.2. And so you would get normal force is equal to 1,120 newtons. For B, same thing, except this time we're plugging in negative 1.8 because it's going down. So we would do negative 1,000 equals 100 times negative 1.8 and solve, and you would get normal force equals 820 newtons. And that's what you got to do for 84. Number 85. No, is it 85? Yes, it's 85. Number 85. You're drawing a free body diagram for a 4 kilogram box sitting on a table. The box is accelerating at a rate of 4 meters per second squared to the right, and there's a friction force of 12 newtons. So if the mass is 4 kilograms, then that means that the weight would be 40 newtons. It's not accelerating downwards, so the normal force has to be 40 newtons. So this would be normal force, force of gravity. We've got a 12 Newton force of friction, and it's accelerating to the right. So the acceleration is this way, so the friction force has to be the opposite way. So it's 12 newtons. And now we have to find out what this force is to get it to accelerate. So the way we do that is basically we would do F net equals ma. Notice that the force of gravity and the normal force are going to cancel. So we're going to be left with the force that we're applying minus the force of friction equals 4 times 4, mass times acceleration. And so if you do this, you would get force equals 16 plus 12, or force is equal to 28 newtons. That's an 8. There we go. Okay? So that's 85. Number 91. What is the force exerted by a spring where K is equal to 400 meters when it's stretched 0.6 meters in the positive direction? Basically, this is the way it would look. It's stretched in the positive direction. So that's not really all that important. You just do force equals Kx. So you would do equals 400 times 0.6, and you would get 240 newtons. That's a 240. 240 newtons is the force. Okay. Next one is 102. What is the magnitude of acceleration caused by the force of kinetic friction acting on a box sliding across the floor on a level table? So imagine that you just take a book or a box. This is a box, sorry. You take a box and you slide it across the floor. Now, the only things acting on that box would be the following items. Okay, you would have, first of all, the normal force up and the force of gravity down. Those two things are going to cancel out, so the normal force would be equal to the force of gravity, which is mass times 10. Now we know that those two things cancel out because it's not moving up or down. The only other thing acting on it would be friction. So friction would be equal to the net force on the object. If friction is equal to the net force on the object, then friction is equal to mass times acceleration. Okay? Now, friction is equal to mu times the normal force. But we know the normal force is mass times 10 from this formula right here. So you would do 0.3 times mass times 10 equals the force of friction. Then plug this in down here, and you would get 0.3 times mass times 10 equals mass times acceleration. Cancel the masses, and you would get 3 equals the acceleration. 3 meters per second squared. Okay? On the next one, number 119, you have a 4 kilogram box is sitting in the back of your 1,400 kilogram car with a coefficient of static friction of 0.4. So we know the mass of the box is 4 kilograms. The mass of the car is completely irrelevant. We don't really care about that because we're looking at only the box. We know the initial speed is 15 meters per second, and we want to know the minimum stopping distance without the box sliding. So what basically we're doing is we're going to match the threshold for static friction. Because if static friction is equal to the mass times the acceleration, then the box will not move relative to the car. Okay? So if this is true, the box will not move. Okay? And so that's what we're going to do. We're going to solve for what A would have to be in order for the static friction to equal the mass times the acceleration. So again, the only thing acting on this box are normal force, force of gravity, and friction. And just like before, the normal force is equal to the force of gravity, which is mass times 10. And so we can solve for it. We got mu, which is 0.4, times mass times 10 equals mass times acceleration. Mass cancels. 4 meters per second squared equals the acceleration. But that's not the answer. It asks us to find the distance, right? So we need to look for the distance. So what we're going to do is we're going to see what we have. We have V naught. We know the final velocity, by the way, has got to be 0 because it's asking us to come to a stop. So we don't have time. So remember, when you do not have time, the formula that is most easy to use is V squared equals V naught squared plus 2AX, X being the symbol for distance. So you would do 0 squared equals 15 squared plus 2 times A. Now A here is 4 meters per second squared, but remember friction would be negative, so technically this should be negative and it would be negative 4 meters per second squared times x. So then we get 15 squared is 225, so negative 225 equals negative 8x. Solve for x, and you would get x is equal to 28.7 meters, maybe 29 meters. Okay? I am sorry, I miswrote that. It's 28.1 meters. My bad. Depending on how you rounded it, you could have gotten anywhere between 28 and 29. It just depends on whether you use 9.8 or 10. Okay? Number 122. How much force is required to push... Sorry, how much force is required to start moving a 2 kilogram block of steel on dry steel if there is a 5 Newton force opposing you? And we know that for steel, the mu s is 0.8, and we know that the mu k is 0.5. So we know there is a 5 Newton force opposing us, right? Whoops. But there's also going to be a frictional force opposing us as well. So the free body diagram is going to look something like this. You're going to have a 5 Newton force back, and you're also going to have a frictional force backwards, okay? And then you're going to have a force you're pushing forwards, a force of gravity, and a normal force. Now, like most situations where you've got something sitting on a table, the normal force and the force of gravity cancel out. So for both of these, the normal force is equal to the force of gravity, which was equal to mass times 10. Okay? The reason we have to know that is because in order to find friction, what do we need? Well, friction is equal to mu times the normal force. So friction is equal to 0.8 times the normal force, which would be 2 times 10. So you would get 20 times 0.8, which would give you a frictional force of 16 newtons. Okay? Which means that then the forces would look like this. You would have 5 newtons back and 16 newtons back. So basically what you need in order to get it moving is a 21 Newton force. Okay? So you would need a 21 Newton force this way to counteract the 21 newtons in the other way. So once you reach 21 newtons, anything like the slightest bit more than 21 newtons is going to get it to move. So 21 newtons would be your answer here. Now to keep it moving, it's different because once it's moving, remember the coefficient of friction drops. So now friction is equal to mu k again, but now it's the 0.5 times mass times 10. And so this would be a frictional force of 10 newtons. Okay? Now, same thing. You've got 5 newtons this way, but now you have 10 newtons instead of 16 newtons this way. And then you're counteracting it, you would need a force of 15 newtons. So if you were keeping it at 15 newtons, that means the net force would be 0, and it would maintain a constant speed. For the last question, number 125, you are going to be dealing with, let's see, just the weight of something on the earth. So basically, you just need to know that anytime you're looking for weight, it's just the force of gravity equals mass times 10. In this case, they're using 9.8 instead of 10. Just FYI if that confused you. So you would just do 300 equals mass times 9.8 divided by 9.8, and you should get 31 kilograms. Okay, equals mass. Alright? That should sum up everything. Feel free to let me know if you have any other questions. I will be happy to help.